Okay. Suppose an object is initially at a position, say 2, 3, and assume its velocity is given by the vector 4 cap minus 2 cap meters per second. Okay. I want you all to find out its final position at t is equal to, let's say, 2 seconds. Okay. Solve this quickly. Initial position is given, velocity is given. You are asked to find out its position after 2 seconds. Try. Can one of you tell me the idea first? How are you going to start solving this problem? Using velocity, how to find out where the object ends up?
Sir, V is equals to final position minus initial position by time.
So you are saying velocity is displacement by time.
Yes, sir.
But Pawan, tell me correctly, what quantity is displacement by time exactly? Or what does displacement by time actually give you?
Velocity, sir.
In velocity also there are different types. There are two types of velocity.
Average velocity.
Displacement by time gives you average velocity, correct. Now this velocity 4 cap minus 2 cap, is it instantaneous or average, or you cannot say? Or for both you can take? What do you think?
Sir, instantaneous.
Okay. Do you think it will change from instant to instant? Like, do you think it's a variable velocity or a constant velocity? By looking at the equation, you can tell.
Sir, constant.
Constant, right? So at t equal to 0, it has this much velocity. At t equal to 0.5 seconds also, it will have the same velocity. At 1 second, 1.5 second, 2 seconds, throughout it will have the same velocity, right?
Yes, sir.
So if the velocity always remains same, do you think average value will also be 4 cap minus 2 cap only or not?
Yes, sir.
It's a quantity which is not changing. If a quantity does not change, the instantaneous value and the average value will be the same. Okay. So I'm telling this to all of you, not just Pawan. Since the velocity is constant, you can take it as instantaneous velocity. You can even take it as average velocity. Doesn't matter. If a quantity remains constant, average value will be equal to that constant value only. Okay. Right. So you can equate it to displacement by time, that is final position minus initial position divided by time. From that, you will get the final position. Solve it quickly, all of you. Type your answers in chat. Okay, I got one answer as 10 I cap minus 1 j cap. Okay, it's simple. See, you know initial position and you need to calculate the final position. So what you need to first find out is displacement. And since velocity is constant, you can use displacement is velocity into time. So 4 I cap minus 2 j cap multiplied with time is 2 seconds. So the displacement becomes 8 I cap minus 4 j cap. And we know displacement by definition is final position minus the initial position. Therefore, the final position becomes 8 I cap minus 4 j cap plus the initial position. Initial position can be written as 2 I cap plus 3 j cap. So effectively it becomes 10 I cap minus 1 j cap. Okay, not a big deal. Let's try one more question. Suppose velocity of an object is given like this. 2t I cap minus 3t square j cap meters per second. Vanilla, tell me, is this constant velocity or variable?
Variable, sir.
Variable, good. I want you all to calculate the displacement from t is equal to 0 to, let's say, t equal to 2 seconds. So in the first 2 seconds, you all have to find out the displacement. Try. Can one of you tell me the idea first? This is a variable velocity. How are you going to calculate displacement? Pawan, you have given the answer, but how did you calculate the displacement?
Sir, integration.
Good, good. So see, velocity by definition is rate of change of position with respect to time. That's all. So dr, that is the small change in position, becomes velocity multiplied with small change in time. Integrate both sides. Integral dr becomes delta r. Because dr is a small change in position, you integrate, means you add all the small changes in position, you get the total change delta r. That becomes equal to integral v dt. And delta r is nothing but displacement. Okay. So displacement is integral velocity with respect to time. Velocity is 2t I cap minus 3t square j cap. I'm not writing the units. Dt. You can split this into two separate integrals. And last class we solved some questions based on differentiation. And there we took I cap and j cap as constants because they are. Okay. I cap is a unit vector in the positive x direction. Its magnitude is 1. Its direction is always positive x. So it's fixed. J cap is unit vector in positive y direction. Its magnitude is 1. Its direction is always positive y. That is also fixed. So just like 2 and 3, I cap and j cap are also constants. You can put them outside the integral. So it becomes 2 I cap integral t dt. That's the first part. Minus 3 j cap integral t square dt. That's the second part. And limits for time will be from 0 to 2 seconds. That's also the displacement effectively becomes 2 I cap. Integral t dt is t square by 2. The 2's can be cancelled. You still have to substitute the limits. Minus 3 j cap. Integral t square dt is t cube by 3. The 3's get cancelled. You still have to substitute the limits. And the answer becomes 4 I cap minus 2 cube is 8 j cap. meters. That is the displacement in 2 seconds. Okay, so I just wanted to show you that during integration also, the I cap, J cap terms can be kept outside the integral. They are constants. Okay, so next worksheet, I'll send you more questions like this. You practice them. Right. So let us now move on to motion in a plane, that is motion in 2 dimensions under gravity. It's also called projectile motion under gravity. We'll begin with a simple case. Assume this is ground and a ball or an object is projected from the ground along some direction like this. Let's say the initial speed is u, means you are throwing it with a speed u at an angle theta with the ground. Okay, it's not compulsory that they will always give you the angle with the ground only. They can give you angle with the vertical direction as well. Okay, but for now let us assume the angle theta is the angle made with the ground. Okay, now what you are expected to do is you should be able to tell everything about this object. Okay, what is going to happen to it till it strikes the ground again. Okay, means as long as it is under gravity, what is going to happen to this object is what you should be able to say. Now, if you remember, in motion in a straight line, we discussed motion under gravity in 1 dimension. Okay, if an object is projected with a speed u like this, straight up, we know it will rise up to a certain height, become too slow, it will stop and then come back along the same straight line. Okay, so we derive time of ascent, Hmax. We know how to tell velocity at any height by using equations of kinematics. Okay, we can tell almost everything about that object till it strikes the ground. Now we should be able to do the same in 2 dimensions when a ball is projected like this. Okay. Vanilla, tell me, if we project a ball like this at an angle, what happens to it?
Here it
Means,
moves to a certain height and fall down.
okay, it rises up to a certain height and then falls, correct? What kind of path does it follow? Straight line or curve?
Curves, sir.
Curved path, right? So it will go somewhat like this. It will reach a certain maximum height and then fall back to the ground. Okay. Aishwarya, tell me, after projection, does this object have acceleration or not?
Yes,
Okay, what acceleration does it have?
acceleration due to gravity.
Acceleration due to gravity, correct. Okay. Fine. So we all know that it is gravity that makes the ball come down. Okay. In fact, if gravity had been absent, air resistance also absent, then no acceleration at all, the ball would have kept going straight like that. Okay, but that is not what happens in this case. Okay, so what we should be able to calculate now, the first things are this maximum height that it reaches, that is how high does it rise above the point of projection, that you should be able to tell. And we know the first half of the journey, it's called ascent. You should be able to find out time of ascent. The other half of the journey is called descent. You should be able to find out time of descent. Combine time of ascent and time of descent, it becomes time of flight. Okay, ascent, descent together becomes flight. Okay, so we should be able to calculate all these things. And keep in mind, there is an assumption we make. We assume that air resistance is absent. Okay, so ignore Air resistance. Air resistance is nothing but air friction or air drag. Okay, you can call it air drag. Fine. What else do we know? We know the acceleration of this object, that is acceleration due to gravity. Fine. Now, in the last class and even the class before that, I told you, if you ever want to find out anything about motion in 2 dimensions, you will have to split the motion into 2 separate one-dimensional motions, which happen simultaneously. Okay, so we'll be taking help of vectors here. We'll be using components. We discussed in the last class that the x components of velocity and acceleration, they dictate how the object moves along the x-axis. The y components of velocity and acceleration dictate how the object moves along the y-axis. Put them together, you will get to know how the object moves on a whole. Okay, on the whole. Okay. So since this is motion in a plane, we will have to take help of vectors and we'll have to choose 2 axes first. Let's consider the ground to be along the x-axis. And let's take the vertical direction, that is the upward direction, as the y-axis. Like this. So horizontal is the x direction, vertical is the y direction. Now observe that initial velocity vector. Okay, let me draw it separately. Okay, we'll take it a little longer just for us to be able to visualize clearly. Initial speed is u. Speed is nothing but magnitude of the vector. We know the magnitude and we know what angle it makes with x-axis, right? Pawan, tell me, how much is the x component of initial velocity? If the velocity, if magnitude is u, angle is theta, how much is the x component?
Sir, u cos theta.
U cos theta, correct. With the x-axis, it's making the angle theta, so the component becomes u cos theta. So I'm writing initial velocity's x component is equal to u cos theta. Fine. Vanilla, tell me how much is the initial velocity's y component?
U cos 90 minus theta, sir.
Right. And cos 90 minus theta is equal to?
Sin theta.
Sin theta, correct. So initial velocity's y component becomes u sin theta. Okay, you can call it you can call them ux and uy. Therefore, the initial velocity as a vector can be written as u cos theta I cap plus u sin theta j cap. Now see, we assumed the projection is tilted towards right. I mean the velocity vector, initial velocity vector is tilted towards right. So we got a positive x component and it is tilted upward. So we have a positive y component. It's also possible that in some question, you are given an object projected like this. Then its x component will be towards left, negative. Okay. Y component will be upward only. So you'll take it positive. It depends. Okay. Right. So this is the initial velocity written as a vector. That's fine. Next thing we need to do is write acceleration as a vector. Can one of you quickly tell me what acceleration this object has after being projected? Anyway, the answer has already been given. The acceleration after being projected is g downwards. Okay. Now we took horizontal direction as the x-axis, vertical upward direction as the y-axis, but gravity always is downwards. G is the magnitude. Downward is the direction. That is minus j cap is the direction. Therefore, Yusuf, can you tell acceleration as a vector in terms of I cap, j cap? The magnitude is g, it is directed downward.
So minus j cap?
Only minus j cap.
That doesn't seem to go in x direction.
Yeah, good. There's no x component, but y component itself, is it just minus j cap? If you're saying it is minus j cap, You are saying it is minus 1 j cap. You are fixing the magnitude as 1. But acceleration due to gravity, its magnitude is not 1. So I'm telling you the magnitude is g. Based on that you tell.
So minus j cap.
Correct. Minus g j cap. That is the acceleration of the object. Fine. Now, initial velocity u cos theta I cap plus u sin theta j cap. You can write it as ux I cap plus uy j cap. So we know the x component of initial velocity, y component of initial velocity. Acceleration is minus g j cap. So it's like 0 I cap minus g j cap. So acceleration in the x direction is 0 plus acceleration in the y direction is minus g. Okay, I'll write it here. Ax is 0. Ay is minus g. J cap. Why we do this is so that we clearly know the x components and y components. Now see whether you are asked to do this or not. If you want to analyze motion in 2 dimensions, you have to do this on your own. You have to write velocities, accelerations. Sometimes you'll have to write positions also as vectors. Okay. Right. Now if you observe, the acceleration does not have an x component. If there is no acceleration in the x direction, the velocity in the x direction will not be disturbed because acceleration changes velocity. Either magnitude or direction or both. Acceleration changes velocity. But if acceleration is not there, velocity will not change. So that's the first thing you need to remember about 2D motion under gravity, motion in a plane under gravity. So we can write it here. Since acceleration in the x direction is 0, velocity in the x direction does not change. Okay. How much was the velocity in the x direction initially? See and tell all of you. How much is the velocity in the x direction initially? It's on the screen.
ux I cap, sir.
U cos theta I cap or ux I cap, correct. So later on also, during flight, anytime during flight, it will have the same x component. Fine. So this thing remains constant. Or, okay, this is initial velocity. Later on, if you find out final velocity at any time during flight, it will always have the same x component. Okay. And if you visualize the y component, initially the y component is pointed upward, but we know gravity is downward. Aishwarya, tell me, if velocity and acceleration are in opposite directions, what happens? Generally, if velocity and acceleration are in opposite directions, what happens?
The velocity will start decreasing.
What did you say?
The velocity will start decreasing, then it will become 0 at some point.
Velocity decreases and becomes 0 at some point. Correct, correct. So here, that is what happens to the y component during ascent. You see that the y component is pointed upward. Okay. The ball is thrown up at an angle like this. The y component is pointed upward, but we know gravity is downward. So what should happen? The y component should go on decreasing. So you can imagine something like this. Let me copy paste the diagram. At any instant during flight, the x component of velocity remains the same. Okay. See, initially, you can imagine this much x component and let's say this much y component. Later on, at a random position, if you consider the particle ball, whatever it is, it will have the same x component as the initial one. So I can directly copy paste that vector. The x component does not change. And see, during ascent, y component is upward, gravity is downward. So y component will decrease. Okay, as Aishwarya said, we know if acceleration and velocity are in opposite directions, the magnitude of velocity has to decrease. It has to slow down. So what happens effectively? The y component becomes shorter like this. Compared to initial velocity's y component, this velocity's y component will be less. Now if you take the resultant, the velocity will be like this at that instant. At a later instant, the y component will become even shorter. X component continues to be the same. Y component becomes even shorter. So it decreases, and as she correctly said, at one height, the y component becomes 0. Okay. See, effectively what happens to the y component is like this. Initially, there's a significant y component, slowly decreases further, and becomes 0. At where does it become 0? At maximum height, the y component becomes 0. That is why we call it the maximum height. Because if y component of velocity was still there, it would have moved in that direction. I told you, velocity is what tells you in which direction the object moves. As the object ascends, as it rises up, the y component of velocity goes on decreasing. Then at one point, that is the maximum height, the velocity's y component becomes 0. But x component will be there like this. Or I could have copy pasted also. X component never changes. It will always have the same length. Okay. So that is its velocity at Hmax. It doesn't stop completely. Vertically it stops, but horizontally it will keep moving. Okay. And then during descent, when coming down, consider a random instant like this. When coming down also, the x component of velocity should be the same. See, this will help you in visualization, okay, while solving problems. So try to follow this carefully. The x component remains the same. And because gravity is downwards, the object starts developing a downward component of velocity. The y component will now become negative. And if you draw the parallelogram, why am I drawing the parallelogram? Because you can see that the x component, y component are joined at the tails. If two vectors are joined at the tails, you are supposed to draw the resultant using parallelogram law. So this is the velocity at that time. Let's call it v2. Tilted downwards. Okay. And when it is just about to strike the ground, means when it returns to its launching height. Again, we can paste the x component as it is. And by then it would have developed a significant y component. I mean, significant speed in the downward direction like this. So just before striking the ground, it would have been moving at an angle somewhat like this. It won't strike the ground vertically, it will strike at an angle because the horizontal component of velocity is always there. Then how can the velocity become completely vertical? It has to be tilted only because that x component will always be there. Right. So tell me this quickly, all of you. Which acceleration is responsible for the change in speed? Or which component of acceleration is responsible for the change in speed? Last class we discussed two components of acceleration of parallel, perpendicular. Which one changes speed? What happened? You all didn't revise at all. Aishwarya, your voice is breaking. What did you say? Parallel component. Okay, correct. So the component of acceleration parallel to velocity changes speed. And last class itself we discussed. We know gravity is downwards. You take gravity's component along the line of velocity, you'll get one component like this. That is the parallel component. And you see during ascent, it is opposite to velocity. That's why speed decreases during ascent. tangential acceleration is opposite to velocity, so speed decreases during ascent. But during descent, gravity is like this, always downwards. You take the component of gravity parallel to velocity, it's in the same direction as velocity, right? It's not opposite to it. So during descent, the tangential acceleration that is there, g parallel, it increases the speed of the object. So during descent, it becomes faster. During ascent, it becomes slower. So we can write it like this. Ascent, speed decreases. Descent, speed increases. Right. Okay, but tell me this, Vanilla, you tell, does the speed become zero anywhere? Totally become zero anywhere?
Yes, sir.
Where does the speed become zero?
At Hmax, sir.
Okay, at Hmax, if speed becomes zero. See, generally, speed becoming zero means object not moving. If there's an object here not moving, then due to gravity, it should fall down like this. Vanilla, what do you say? Yes or no?
Yes, sir.
But is that what happens to this ball which is thrown? Does it reach maximum height and suddenly drop down? Sorry. So we don't observe a ball projected at an angle to reach its maximum height and suddenly drop down. Okay, it will continue along that curved path only. That means its velocity does not become zero. Its speed does not become zero there. It's only the y component which becomes zero. The x component will be there, no? X component will
Sir,
always
but
be
its
there.
velocity becomes zero, no, sir.
No. Why are you saying velocity becomes zero? Now, this velocity, this object's velocity has two components. Only one component of velocity is becoming zero. The other component is there. That means velocity is still there. Its velocity in the vertical direction becomes zero. Horizontally, it will still have velocity. Okay.
Okay, sir.
Are you convinced or not?
Yes, sir.
Right. In fact, let's solve a problem first. Assume initial velocity is some 20 I cap plus 30 j cap meters per second. And acceleration is acceleration due to gravity, so minus 10 j cap meters per second square. Now what I want you all to find out is, first, the time when velocity's y component becomes zero. And then again, and what else I want you to find out is the velocity's x component at that time. Okay, try this, all of you. Keep one idea in mind. The x component of velocity and x component of acceleration dictate what happens along the x-axis. The y component of velocity and y component of acceleration dictate what happens along the y-axis. Okay. So I'm asking you to find out the time when velocity's y component becomes zero. Write an equation only in terms of the y component. You can tell. Try this. Vanilla, your answer for the first part is correct only. Calculate the second part. Yusuf, can you tell me how you are going to solve this? How will you calculate the time when the y component of velocity becomes 0? Okay, Pawan, how will you calculate the time when velocity in the y direction becomes 0?
Sir, v is equals to u plus at.
Correct. How much will you take u as?
Sir, 30 meter per second.
Okay, so effectively what you are doing is Vy is Uy plus Ay into t. You are applying V is equal to u plus at only in the y direction. Okay, good. We want this to become 0. Initial velocity in y direction is 30. Acceleration in y direction 10 into t. You get the time as 3 seconds. So in 3 seconds, the y component is going to become 0. But what about the x component? We know Vx is equal to ux plus ax into t. Initial velocity's x component is 20. Acceleration doesn't even have an x component. Therefore, the velocity's x component always remains 20. That means in the x direction, the velocity does not change at all. Same thing happens in projectile motion in 2 dimensions also. Gravity is only in the vertical direction. We know gravity is this way. So it's only the y component that gets affected. The x component of velocity never changes, even at maximum height. Okay, even when the object is at maximum height, it will still have the x component of velocity. It doesn't completely stop. Okay, it doesn't make sense also. If an object stops there, if an object stops somewhere in air, it should fall straight down under gravity. But we don't see that happening. We see that it continues along this path. It continues because it has that horizontal component there. Okay. Right. So we know what happens to the x component, y component. As a whole, speed decreases during ascent, speed increases during descent. Right. Now we need to find out how much is the maximum height to which the object rises. And see, the object undergoes acceleration, and that acceleration is due to gravity. Is acceleration due to gravity a constant acceleration or a variable acceleration? Anyone? Acceleration due to gravity is constant or variable?
Sir, constant.
Constant. At least for small heights above the earth, okay, like the height to which you can throw a ball, it remains constant. Okay, when you go into space or very far away from the earth, then gravity changes significantly. For now, we are not considering those effects. We will take into consideration that effect when we discuss the chapter gravitation. Okay, for now, we'll assume acceleration due to gravity is uniform. Are you all able to see my screen?
No, sir.
Okay, just a moment. There was a power cut here. Just a moment. Now is it visible?
Yes, sir.
Okay. So what we have to derive now is this maximum height. And what do we know? We know the speed with which the object is projected. We know the angle at which it is projected. And we know that acceleration is due to gravity. G is also known. Can one of you tell me an idea to derive an expression for maximum height? We just discussed that acceleration due to gravity is constant. So equations of kinematics are applicable. Which equation can we use to derive this height? Which equation of kinematics can help us derive that height?
Sir, v
S
square
equal
minus u
to
square.
Okay, Pawan is saying v square minus u square is 2as. I had another answer also. Someone else was saying something.
S equal to ut plus half at square, sir.
Okay, let us discuss. Pawan, you tell me. If you want to use v square minus u square is 2as. In this equation, which term is height?
Sir, yes.
S is height, you are saying. What does S mean in the equation v square minus u square is 2as?
Sir, displacement.
Displacement. But displacement is the vector drawn from the initial position to the final position. Won't it become this complete vector? This should be S, no? What do you say?
Yes, sir.
Okay, then will that give you height?
No, sir.
Okay. Vanilla, you said we can use S is equal to ut plus half at square. Same thing. In this also, S is displacement. You will get this total displacement. How do you
We can use Hmax formula, so u square by 2g.
use of that Hmax formula is valid when the object is projected straight up with a speed u. Okay, then the maximum height to which it reaches is u square by 2g. This is a different case, no? So we have to derive a formula in this case now. But actually you can use that formula by making a small modification. Can you tell how you should adjust or what modification you should make to use u square by 2g if you want to? Okay, anyway, let us discuss this in complete detail. First, tell me this, all of you. Suppose this is the ground level. Consider two cases of projection. One case where the object is projected straight up with a speed u, and one case where the object is projected at an angle but with the same speed u. Do you think the ball will rise to the same heights in both cases? Like from your everyday experience or based on your logic, you tell me, do you think they will both rise to the same height?
No, sir.
In which case, will the maximum height be greater, Yusuf?
So from the first one,
First one. Why, on what basis are you able to tell that? You didn't actually throw two balls and see, no? How could you say that?
So it loses no speed because of the direction.
What did you say?
It doesn't lose the acceleration due to distance and etc. It just goes up straight up high. It comes down.
Okay,
It's when
okay,
travels a certain distance and then comes down.
okay. Okay, we can justify it like this. Listen, all of you. In the first case, all the velocity is in the y direction. Okay. Now see, height is displacement in the y direction. Okay. We want the object to go away from the earth. We want the object to move in this direction. To make it move in this direction, it's the velocity in that direction that matters. Now, in the first case, all the velocity u was in that direction itself. But the second case, if you see, there is an x component like this, and there is a y component like this. And we know that components are not as strong as the original vector. Okay. So in this case, the y component is less than u actually. So it won't be able to take the object to that much height as in the first case. Is this clear to all of you? If you have any questions in this, you can ask. The first object will reach or will attain more height. Okay, just a moment. I am switching my net connection. Yeah, is my screen visible to all of you?
Yes, sir.
Okay. So definitely, if all the velocity is pointed in the upward direction, then that will, in that case, the object will go to a greater height than just a component being pointed in the upward direction. Okay. And we know that in this case, the answer is u square by 2g. Then in this case, the answer cannot be u square by 2g. It should be less than that. Definitely less than that. Yusuf, are you convinced with this?
Yes, sir. Yes, sir.
Okay. Now one of you tell me an idea to calculate that maximum height. Okay. See, maximum height is not the actual displacement of the object. The actual displacement, we had visualized it just before also. It is from the initial position to this position. This is the actual displacement of the object. But maximum height, don't you think it's the y component of that displacement? Yes or no? Is Hmax the y component of its displacement from the point of projection to that point or not?
Yes, sir.
It is. Okay. So what we are looking for is not complete displacement. We are looking for displacement only in the y direction. So that's the main idea here. Hmax is nothing but displacement in y direction. Now tell me, any one of you, how can displacement in y direction be calculated from the initial instant to that point? Let's call the point of projection as A. Let's call this maximum height point as B. And the point where it strikes the ground again, let's call it C. So from A to B, how to find out the y component of displacement? Tell me this first of all. Y component of displacement, or what happens along the y-axis, is dictated by what, or depends on what?
Y component, sir,
Of?
of the object.
No, you should not say y component of object. Vector quantities have components. Objects don't have components. What happens in the y-axis is determined by what? Anyone? See, generally, what happens to an object or how an object moves is dictated by its velocity and acceleration vectors. Okay, how much velocity it has, how much acceleration it has. So if you want displacement in the y direction, it depends on velocity in the y direction and acceleration in the y direction, both of which are known to us. We know that initial velocity in y direction was u sine theta. You can keep it as uy itself if you want. Okay, that is u sine theta. And acceleration in the y direction is minus g. We know these already. We need displacement in the y direction. Now one of you tell me which equation of kinematics can help us calculate displacement in this case. U is known, A is known. We need to calculate S. Which equation can we use? Okay, Pawan, tell me, what are all the equations of kinematics which involve S?
Sir, S is equal to GT plus half at square.
Okay, wait, S is equal to, so now you will write Sy is equal to Uyt plus half Ay t square. That is one equation. Are there any other equations of kinematics which involve S?
Sir, V square minus U square is equal to 2S.
Okay, so you will be writing Vy square minus Uy square is equal to 2 Ay Sy. Okay. Vanilla, you tell me, to use the first equation and find out displacement, what all do you need to know?
Time and initial velocity, sir.
Yeah, first equation. Where is final velocity in the first equation? What did you say?
Time and initial
Time.
velocity.
Okay, okay. Sorry. Final. I heard it as final initial velocities. No. Okay, you need to know time and initial velocity and acceleration. Correct. Initial velocity is known to us. Acceleration is known to us. But do you know the time it takes to go from A to B?
No, sir.
We don't know. So we can't use that equation. See, this is how you are supposed to think. My question was, which equation of kinematics can be used to calculate displacement in y direction? You think of what all equations are there which can give you displacement, and you think of whether sufficient information is there to use those equations. So you can't use S is equal to ut plus half at square to calculate the displacement. Then we are left with only one choice, this one. Aishwarya, you tell me, to use this equation and calculate displacement, what all do we need to know?
Initial velocity, final velocity, and acceleration.
Initial velocity, acceleration are clearly known. Do you know the final velocity in the y direction when it goes from A to B?
Sir, it will be 0 in the y
Good,
component.
good. Correct, correct. We know that since B is the point of maximum height, the velocity in y direction there becomes 0. Okay, we had discussed this before also. So that is also known to us. And since we know these three, this is the appropriate equation to use to derive Hmax. Okay, now do it all of you. You know how much is velocity in y direction at point B. You know how much is velocity in y direction at point A, that is initial velocity is y component. And you need, okay, you also know acceleration in y direction. You need displacement in y direction. Derive this quickly, all of you. Derive the expression for Hmax. Some of you may be knowing it already, but do it now. Nishita, any answer for Hmax? Okay, anyone? Did you get any answer for Hmax? This is easy only, no? Pawan, tell me, what are you substituting? What values are you substituting? How much is Vy?
Sir, U square sin square theta by 2G.
Okay, U square sine square theta by 2g, correct. Vy is 0. Now Uy, let's keep it as it is. 2 Ay is minus g multiplied with displacement in y direction. Listen, all of you. Like, you should be able to tell the answer in terms of components also. You'll understand why. So effectively, you get minus uy square is minus 2g sy. Minuses cancel. So sy, displacement in y direction, becomes uy square by 2g. Therefore, Hmax of this object is uy square. That is the square of y component of initial velocity divided by g. And see, when I first asked the question for Hmax, Yusuf said u square by 2g. Okay, sorry, there is a 2 also. Yusuf said u square by 2g, but see what we got. uy square by 2g. Now he said u square by 2g because he remembered that case. Vertically projected object. Okay, where is it? Okay, I erased it. Never mind. So if an object is projected straight up with a speed u, all the velocity is in y direction. So in that case, uy itself is u. I mean, in the case where the object is projected straight up, initial velocity is y component is the complete initial velocity u. So there we got u square by 2g. But here in y direction, we don't have the complete velocity u. We only have a component. And that component is what takes it to the maximum height. So it's very similar to u square by 2g, but in place of u, you should substitute the y component now, uy square by 2g. And we know that initial velocity in y direction is u sine theta. So this becomes u square sine square theta by 2g. But this is a risky formula to remember. Why? Here in this derivation, we assume theta is the angle made with the horizontal. If angle is made with horizontal with the x direction, then x component becomes u cos theta, right? Suppose in some question, they give you this angle instead of angle with horizontal, they give you angle with vertical. Okay, all of you observe the diagram. If they give you that angle, let's say as beta, then tell me how much is the y component? If speed is u, angle with y-axis is beta, forget about theta now. Theta is not there, only beta is given. How much is the y component?
U cos beta, sir.
U cos beta. And then the answer will become u square cos square beta by 2g. So that is why remembering this formula is risky. Because if you remember it as sine, then like sometimes in a hurry, you may make that mistake. You may forget that the angle theta should be with the horizontal. Okay. That's why remembering it this way is better. uy square by 2g. Get the y component and put it here. Okay. So that's what I said. That is the problem with remembering cos and sine. X component cos, y component sine. Many people remember it like that. But sometimes that will be that will lead you to mistakes. Okay. Anyway, we will stick to what we considered. We considered theta as the angle with the horizontal. So in that case, the angle, the Hmax becomes u square sine square theta by 2g. But generally it is uy square by 2g. It's the y component that matters for Hmax. Remember that. Okay, we got the maximum height. Good thing. Next, we need to derive time of ascent. Time taken to go from the point of projection to that maximum height. So time taken to go from A to B is what we want. Yusuf, do you remember time of ascent when the object is projected straight up? Anyone? If not, Yusuf. Time of ascent when the object is projected straight up.
The root of 2h by g.
No. Root of 2h by g is the time of descent. To fall by a height h, it takes a time root of 2h by g. Time of ascent will be in terms of initial speed u. Try to recollect.
Sir, u by g.
U by g. Correct. So when all the velocity is in the y direction, I'll just draw that case here. when all the initial velocity is in the y direction, we get the time of ascent, that is the time taken to reach the maximum height, as u by g. But now we only have a component. Look at the diagram on the left. The velocity in y direction is only uy, okay, not complete velocity. Can you guess what the time of ascent is going to be? Like, draw an analogy between that case and this case. There all the velocity u was in the upward direction, so we got u by g. Here only uy is there in the upward direction, so how much should you get? How much should the time of ascent be?
Uy by g, sir.
Uy by g. It should be uy by g. Correct. Let's see if the equations tell the same thing or not. Okay. Again, you know what all are given. We know the initial velocity, we know its components, we know acceleration's components, and we know the y component of velocity at b. It is 0. Of course, we know the x component also. X component always remains the same. Vx is equal to ux. Okay. And anyway, that is of no use now. Tell me which equation can be used to find out the time taken to go from A to B.
S equal to ut plus half at square.
Okay. How much will you take S as? Because what we want is T. If you want to use S is equal to ut plus half AT square, you should know S U A. U is known, A is known. Okay. How much will you take S as?
Uy
Displacement.
square by 2g, sir.
Okay, you'll take velocity displacement in the wider Hmax you will take. Okay, good only. It's an idea that works. But the problem here is you want to write displacement as uy square by 2g. You can do that. Initial velocity is uy into t plus half ay is minus g into t square. The problem is that this is a quadratic equation. It's time taking to derive t. Okay, you have to use the formula for roots of a quadratic equation, which makes it complicated. So we are not going to use this. Then tell me, what is the only other equation of kinematics which can give us time?
V is equal to U plus 80.
V is equal to u plus 80. That's all. We will apply it in the y direction because we know final velocity in y direction. So we are going to use Vy is uy plus ay into t. Now you see there is no quadratic equation. This is easy to solve. Okay. So anyway, at B, at point B, we want the time taken to go from A to B only. No, at B, velocity in y direction is 0. At A, let's keep it uy only. Later we'll substitute as u sine theta, that risky thing. Plus acceleration in y direction is minus g multiplied with time is time of ascent. So send uy this side, you get minus uy is minus g into time of ascent. Minuses cancel. Send g this side. As expected, time of ascent turns out to be uy divided by g. If all the velocity is in y direction, then it is u by g. If only a component is there in the y direction, then it is that component divided by g. Okay, as expected. And if you are sure that theta is the angle with the horizontal, then x component is u cos theta, y component is u sin theta. In that case, the time of ascent becomes u sin theta divided by g. But again, you need to be very careful. You need to be sure that theta is the angle with the x-axis, not with the y-axis. Then only you can use this. Otherwise, generally remember uy by g. Okay. Next thing we need to find out is the time of descent. Let us visualize descent separately first. Okay, we'll just finish off all these basic derivations today. Next class, we'll discuss some high-level stuff in these cases. So the next thing we want to find out is the time of descent. Tell me, from where to where do you call descent in this diagram? From which point to which point is it called descent? Object is rising up and then falling down to the ground. From where to where? Which part of the journey do you call descent?
Sir, B to C.
B to C, wherever it is coming down, we call it descent. Correct. So now we want the time it takes to go from B to C. What do we know about the object at point B? Anyone? Descent is from B to C. Okay. What all do we know about the object at point B?
Sir, Vy 0, Vx something value.
Okay. At point B, the velocity is x component. The x component always remains the same. Initially, whatever it was, it will always be the same. Initially, the x component was u cos theta. Okay. I'll write it in green itself just to avoid confusion. This component is u cos theta. Okay, you can call it ux also. And the y component, which was upward, uy is u sin theta. Okay. Since there is no acceleration in the x direction, the x component of velocity always remains the same. So Vx is equal to ux is equal to u cos theta. Okay, we know the x component of velocity. Next, we know the y component of velocity also there, 0 at point B. Next, do we know the height of that point? Do we know the height of this point B?
Yes, sir.
How much?
Uy square by G. 2G.
Uy square by 2g. Correct. So we know its position also. Fine. So I'll write it here. Height of that point B is uy square by 2g. And okay, good. I'm happy that you said uy square by 2g instead of u square sin square theta. It is better to remember it like this. Okay, so we know a few things about B. Now see, for descent, B is the starting point. So we know the initial velocity for descent, because if you know velocity at B, it means you know initial velocity of descent. Okay, and we also know from what height the descent is beginning. Okay. Now tell me this, anyone, which equation can be used to find out the time taken to go from here to here? That is what we need now, time of descent. Which equation can you use?
V equal to U plus 80, sir.
Okay, let's see. You want to use V is equal to U plus 80. Our aim is to calculate time. If you want to calculate time from this, you should know acceleration. Acceleration due to gravity, we know. Initial velocity at B also we know. Do you know final velocity as it goes from B to C? Do you know its velocity at C? If you're thinking so much, that means you don't know. Okay, as of now, we have not derived. So this equation will not be useful to calculate the time. What is the only other equation we are left with?
S is equal to UT plus half AT square.
S is equal to UT plus half AT square. Okay. It's a quadratic equation, but sometimes it will be easy to solve. S is equal to UT, okay, U into T, sorry, plus half a T square. Our aim is to calculate time, that's fine. For the journey from B to C, do you know the initial velocity? Do you know velocity at B or not? Quickly tell yes or no.
Yes, sir.
We know the velocity at B. So for descent, we know the initial velocity. And from B to C, do we know the displacement? I'm sure we don't know the complete displacement. But do we know anything about the displacement from B to C? At least a component of the displacement or anything like that. The total displacement is from here to here, which is not known to us. But do we know the x component or y component of this displacement? Anyone? We know the y component, no? The displacement vector is the gray one. Its y component will be from here to here, which is Hmax itself. Right? So we know the displacement's y component from B to C. It is Hmax, but in the downward direction. Since we don't know the total displacement, but we only know displacement's y component, we are going to use this equation, but only in the y direction. Sy is uy into t plus half ay into t square. Okay, how much is Sy? From B to C, the displacement is downwards in the y direction. Okay, so you should take it as negative of Hmax. Okay, what is the initial velocity in y direction at B? Or let's not use the word initial. What is the velocity in y direction at B?
Sir, 0.
0. So for the journey from B to C, initial velocity in y direction becomes 0. Plus half. We know acceleration is always gravity minus g t square. Since this term becomes 0, it is easy to calculate t from here. Minus minus cancel. You get h is equal to half g t square. That means t square is 2h by g. That means t, that is the time of descent, is under root 2h by g. Now this formula looks familiar. Can any of you tell me? One of you told me this formula also in today's class itself. What formula is this? When is this to be used? Under root 2h by g. What does it help you calculate?
Time of descent, sir.
In which case? How should the object be released? And there are some conditions for it.
For curved path కాకుండా straight line.
If you drop a ball, when it falls straight down by a height h, it takes a time of under root 2h by g. Dropping means initial velocity should be 0. So if something is dropped from rest, then to descend by a height h, it takes this much time. But see what happens here. In this case, let me erase all this, just a moment. Just to make the diagram clear to observe. Look at only the descent part. Descent is from B to C, right? So let's consider only descent. Now at B, the velocity in y direction is 0. It only has a velocity in the x direction. Okay. Then at this point, it will have velocity in x direction. It will also have velocity in y direction. And the last point before it strikes the ground, it will have x component as it is. It will have a longer y component like this. Okay. So at B, the initial velocity in y direction is 0. So if you imagine only the motion in the vertical direction, only motion in the y direction, it's effectively like this. At this point, the object did not have any velocity. Then at this level, the object has some velocity in the y direction downward, and at the bottommost level, when it is just about to hit the ground, the object has more velocity in the y direction, like this. And what height did it descend? The total height descended is this Hmax. So you can visualize this as falling by a height h. And in this case, the time taken should be under root 2h by g, which is the same even in this case. Okay. Vertically, during descent, what happens is this. The ball is dropped from rest vertically. Horizontally, it is moving because it has that x component of velocity. But see, x component is parallel to the ground. No, it won't help the object go up or come down. So those green arrows that are there, they are taking it sideways. They're not taking it upward or downward. So the x component of velocity never interferes with what happens in the y direction. Okay, vertical direction. So vertically, if you visualize the motion of this body during descent, it is like a ball dropped from rest. Are you all able to understand this? Whatever happens in the right side case vertically, same happens in the curved path also vertically. Is that clear? If you have any questions, you can ask. Try to relate them. Okay. So in the vertical direction, if you observe, whatever happens when you simply drop a ball downwards, the same happens in 2D projectile motion as well. Starting from Hmax, at Hmax, the velocity is only in the x direction. There's no y component of velocity. So in the y direction, it's like starting from rest. Then after moving some distance, it gets velocity in the y direction. Then after moving some more distance, it gets some more velocity in the y direction. So in the y direction, it is under free fall. Okay. It's like that. That's why we get the same formula for time of descent. And we know Hmax is uy square by 2g. We'll substitute that here. And this you will see it becomes uy by g. Like if you put Hmax as uy square by 2g, 2 gets cancelled, you get uy by g. How much was time of ascent, if any of you remembers? How much was the time taken to go from A to B?
Sir, uy by g.
Uy by g. Okay. Time of descent is also uy by g. If time of ascent is uy by g, time of descent is uy by g. Aishwarya, tell me, what is the total time of flight?
So 2
Okay. Time of ascent, time of descent are both uy by g. Therefore, time of flight, which is time of ascent plus the time of descent, becomes 2 times of uy by g. And in your textbooks, it may be written as 2u sine theta by g. But you better remember it as 2uy by g. Okay. But again, conditions are very important. That's why you should never remember a formula blindly. Look at the case that we took. The case that we took is a case of ground to ground projectile. Means initial point A and final point C are at the same level. In that case, time of ascent will be equal to time of descent. But suppose something like this happens. Let's say there's a person standing on top of a building. We're going to be solving questions like these. Okay. So let's say there's a person standing on top of a building and the person throws a ball like this. You will see that the ball ascends to a certain height and then it descends to a greater depth. In that case, do you think time of ascent will be same as time of descent? Definitely not. Okay. Only if the starting point and the ending point are at the same horizontal level, time of ascent will be same as time of descent. Okay. If you allow it to fall any longer, time of descent will become greater. If somebody catches before itself, then time of descent becomes lesser. For example, let's say There's a building here. And assume somewhere in the balcony there's a person standing. And from the ground, another person throws something to that person. Gravity is there, so object cannot go in a straight line. It has to follow a curved path like this. Then in this case, there is more ascent, but only less amount of descent, little amount of descent. So here time of ascent will be greater than the time of descent, because you are not allowing it to descend to the same level from where it was projected. Okay. And in this case, time of ascent will be shorter than this complete time, the time of descent. Okay. So remember, time of ascent is equal to time of descent only when you allow the object to come back to the same level, only till it comes back to the same level. Okay, so we got total time of flight 2u by g, 2uy by g, sorry. Just one more thing we will derive. That is the horizontal distance covered before striking the ground. We call it as range. Horizontal range. Simple derivation only. We'll finish it off quickly. Denoted by the symbol R. As you can understand from the name itself, the horizontal range is nothing but the distance from the point of projection to the point where it strikes the ground. So it is the distance, straight distance from A to C. Okay. Can any of you tell me an equation which can help us derive this? How to derive the range? You know what all are known to us. We know initial velocity is y component, x component. We know acceleration. We know Hmax. We know time of ascent. We know time of descent. Means we know total time of flight. How to calculate the range? What kind of a quantity is range? Is it a displacement? Is it a velocity? Is it an acceleration? Or is it not any of these? What kind of quantity is it?
Displacement.
It's a displacement. Then think which equations of kinematics can help us find out displacement, and which of those equations can be used here. Vanilla, you only tell me which equations of kinematics can help us calculate displacement.
Velocity by time, sir.
What? That is completely wrong. Velocity by time will never give you displacement.
Sir, v square minus u square is was 2as.
Okay, let's see. V square minus u square is 2as is one of the equations of kinematics which can help us calculate displacement. Okay. Pawan, you tell me that range A to C is displacement in which direction? Is it in x direction, y direction, or some random direction?
Sir, x direction.
X direction. Okay. Hope you all are able to visualize this. The vector drawn from A to C is a vector in the x direction. So range is basically the x component of displacement, total displacement. That is what we want. Okay. Now, if displacement in x direction is what you want, you should be writing an equation like this. Vx square minus ux square is 2 ax sx, displacement in x direction. Okay. Pawan, tell me, what is the velocity's x component finally? Means at c, what is the x component of velocity? Do you know or not? If you don't know, you can tell you don't know. If you know, tell the component.
Sir, u cos beta.
What is beta?
Sir, అంటే 90 minus theta కదా సార్.
Okay. అది y component అవుతుంది. That is the y component, no? 90 minus theta is with the y-axis. Then u cos 90 minus theta will be with the y-axis. How will that be the final x component? Anyone? Do we know the final x component of velocity or final velocity is x component? We know. Okay. The x component never changes till it strikes the ground. Now c is the instant just before striking the ground. Why are we considering just before striking the ground? Why not after striking the ground? Is because only till the instant before it strikes the ground, acceleration will be acceleration due to gravity. The moment the ball hits the ground will exert a force on it and its acceleration will get disturbed. Okay. So now we are using equations of kinematics assuming constant acceleration. That constant acceleration will be there only during flight, not after it hits something. So at point C, it still didn't hit the ground. It is about to hit the ground. Okay, remember this point. And as long as it is in flight, the x component is always the same because there is no acceleration in the x direction. There's no wind blowing, there's no air resistance. We didn't consider anything of that sort. Gravity is the only thing we are considering. Gravity is in y direction. So in x direction, there's no acceleration. So the final velocity is x component will be same as initial velocity is x component. Because in the x direction, there is no disturbance at all to velocity. Okay. Then if final velocity is same as initial velocity, left-hand side becomes 0. What about right-hand side? Our aim was to derive displacement. Does that mean displacement is 0? What is this equation trying to tell us? Clearly, the displacement in x direction is not 0. The object moved from A to C. It should not come out to be 0. But the left-hand side of this equation became 0. Because final x velocity is same as initial x velocity. What is this equation trying to tell us?
సార్ పార్టికల్ అనేది ప్రొజెక్టైల్ కాకుండా స్ట్రైట్ లైన్ పాస్ అవుతుంది.
What are you saying? It is moving in projectile only, no? How can you say it is moving in a straight line? No.
సార్ అంటే ఇప్పుడు ఒక పర్సన్ గ్రౌండ్ నుంచి ఇచ్చి మళ్ళీ అదే బాల్ వాడి దగ్గరికి రావడం లాగా అంటే ఫైనల్ పొజిషన్ ఇనిషియల్ పొజిషన్ 0 లాగా.
But see, in this equation, we have displacement in x direction, no, not in y direction. What you said is correct for y displacement. Initially, that means at point A, the object is just above the ground. At point C also, it is just above the ground. So initial y coordinate is same as final y coordinate. Okay, initial height is same as final height, 0, 0. But initial x coordinate is not same as final x coordinate. X direction, it has moved. Definitely, it has moved. Okay.
Sir, acceleration is 0.
Acceleration in the x direction is 0. So equation is telling us 0 is equal to 0 into Sx. From this equation, we cannot find out range. Okay. Equation is correct only, but it won't help us find out the range. Now tell me, which other equation of kinematics can help us calculate displacement? Okay.
S
S
is
is
U.
equal to, so you should write Sx is equal to Ux into T plus half Ax into T square. We know acceleration in x direction is 0, so this whole thing becomes 0. Initial velocity in x direction, we'll keep it as ux itself. Do we know the time taken to go from A to C? Have we calculated the time taken to go from A to C?
Yes, sir.
How much?
2uy/g.
Correct. It is nothing but the time of flight. So it becomes ux into 2uy/g. Good. Therefore, range becomes 2ux uy divided by g. So range depends on both x component as well as y component. Now you may ask, sir, range is displacement in x direction. Why does it depend on the y component? Because the time taken depends on the y component. Okay. Therefore, range depends on both x and y components. 2ux uy divided by g. You can write this as 2 times ux was u cos theta, uy was u sin theta divided by g. And in many books, you will find it this way. U into u becomes u square. You will be left with 2 sin theta cos theta. Okay, I'll write it here. 2 sin theta cos theta and divided by g. And 2 sin theta cos theta, according to the rules of trigonometry, identities of trigonometry, becomes sine of 2 theta divided by g. Okay, that is also a formula for range. Okay, so today all we did was derivations in case of 2D projectile motion. Basic derivations we have done. Hmax, time of ascent, time of descent, range. We compared 2D projectile motion to 1D projectile motion. Okay, whatever happens in y direction in this case, the same happens in y direction when the object is thrown straight up. Only thing is, here we are only one component will be in the y direction. Earlier we had studied with the complete velocity in y direction. That's the only difference. Okay, you must have noticed that by now. Okay, we'll stop it here for now. I'll send you a worksheet tomorrow. Tomorrow is what, Saturday? After that, Sunday, no? The next class will be on Monday only. So Saturday, Sunday, you sit and solve problems based on these basic formulas. You apply them as it is. So you will be given how the object is projected. You should find out time of ascent, time of descent, Hmax, range, and some extra questions will be there. But see, you have to solve worksheets. You should give some time for practice. You should apply what you learned in the class, and you should also extend your thinking a little bit. I sent you one message also a few weeks back. The worksheets are meant to extend your thinking beyond what is taught in the class. I mean, based on the principles you learn in class, you can find out some new things. Okay, and that is what they expect you to do in exams like JEE Advanced. Concept, see, throughout the country, all students refer the same textbook. But who can apply those concepts to new situations and solve new questions? Those are the ones who will clear the exam. So that is what is more important. Okay? Practice applying what you learned is very important. Anyway, so first we discussed how you can integrate integrate vectors. Just treat I cap, j cap as constants and integrate. Then we started talking about motion under gravity in 2 dimensions. Fine. Okay, I'll send you the notes. Make a list of these formulas first. See, you have to give some time to this. Maybe some 2-3 hours over the next 2 days, Saturday, Sunday. 1 hour for revision of what we discussed today. Means you have to derive all that on your own. Then 2 hours for practice. Worksheet will be sent tomorrow morning. Okay. Fine, then thank you all. We'll continue on Monday.
Thank you, sir.
Thank you, sir.